So we've got this statement here. We've got that m equals the square root of s divided by t. We're told that s is 3.47 correct to 3 significant figures, and t is 8.132 correct to 4 significant figures. And by considering the bounds of these, we need to work out the value of m to a suitable degree of accuracy, giving a reason for our answer. Okay, so we're going to start by working out the bounds. I'm going to look at s first. And we're told that 3 significant figures, s is 3.47. So we need to think about, okay, so what could have the actual value of s been originally, so that when it was rounded to 3 significant figures, we got this. And what we think about that, we think about the lower bound it could be, and the upper bound. So lower bound for that would be 3.465. So if you think about that, if you round that to 3 significant figures, you get 3.47, which is what we need. However, anything less than this value, so if let's say we had 3.46499999, carry on, when you round that to 3 significant figures, you'd actually get 3.46. So because of that, we know that this got to be the lower bound. So I'm going to draw in this symbol. So you can see I've said that s is greater than or equal to. So if it's equal to this value, we go to 3 significant figures, we get the value we want, or greater than that, we'll get the value we want. Now we need to look at the other end. What's the upper bound? So the highest value it could equal, and still around 3.47 and 3 significant figures, would be 3.4749999. And that just keeps on going. Because if you think about that, any higher than that, if we had 3.475 and I round that to 3 significant figures, that would give us 3.48, which isn't what we want. So this is the highest value we could have. And this works, but it's not very neat writing it like this. What we actually do is we write this as 3.475 and change the symbol here from less than or equal to just less than. And that means the same thing. That's great. So we worked out the bounds of s. Now I'm going to do the same with t. So it's the exact same process as with s. However, this time we're looking at something for 4 significant figures. So you've got 8.132. So the lower bound for that would be 8.1315. So if we go any lower than that and round it to 4 significant figures, we get 8.131. So this is the lowest value that would round to 8.132. And again, for the upper value, that would be 8.1325. And we've still got the sign as less than and not less than equal to, because if we actually had this value, it would round to 8.133, which is not what we want. So it needs to be strictly less than. Great, so here we've done our work working out our bounds. Now we're going to do the second part of the question where it says we need to consider these bounds and work out the value of m to a suitable degree of accuracy. Now m here is defined as a fraction, so I've written something over here that's going to help us. So it said if x is a big number divided by a small number, x will be a big number. It'll be quite a large number. But if x is a small number divided by a big number, then x will be a really small number. And you could try some values out in your calculator and see, and hopefully that makes sense. So we're going to use this fact with the bounds to try and work out the highest possible value for m and the lowest possible value for m. So the lower bound for m, we're going to have the square root of s over t. But we need to think about which value we pick for s and which we pick for t. But because you want the lower bound, so we want the small number. So if we think about the fraction, we want a small number on the top and a big number on the bottom. Well, the smallest possible value we can have on the top is this one, 3.465. So we're going to put that in there. We want a big number on the bottom, and the biggest number we could have here is 8.1325. And we're going to do the same for the upper bound of m. So using the same logic, to get the biggest possible number for m, we want the biggest possible number on top. So that's going to be 3.475. And the smallest possible number on the bottom, so it's going to be 8.1315. What we do is pop those into the calculator to see what we get. So now to see what value we're going to give m to a suitable degree of accuracy. So to do that, we're going to look for the highest degree of accuracy when the upper bound and lower bound round to the same number. So if we look at both these numbers here, so we can round them to 1 decimal place and they both get to 0.2. 2 decimal places, they both get to 0.2. 3 decimal places, okay, so we get 0.229 and 0.229, so that's the same thing. If we go to 4 decimal places, this would be 0.2289, and this would be 0.2292. So at 4 decimal places, the values would be different, but at 3 decimal places, they're the same. So that's the highest accuracy where the upper and lower bound round to the same number. So in this case, we're rounding to 3 decimal places and we're getting the value of m to be 0.229. And it says we need to give a reason for our answer. So give a reason why we've concluded that m is 0.229. And the reason for that is what we've just been talking about, since both the lower bound and upper bound round to 0.229. So we get our first mark for trying to work out these bounds here. We got a second mark for realising we need to sub a combination of the upper and lower bounds into the equation. And we get another mark for this part as well, for choosing the right combination to sub in to get the lower bound and upper bound. We get another mark for getting the correct values here. Then we get the final mark for our answer of 0.229 and our reasoning for all that.